Thank you for tuning in. My name is Molly Welsh, and I'm an environmental scientist at the Narragansett Bay Commission. Today, I'll be presenting on long-term monitoring of water quality improvement following wastewater treatment nutrient reductions. The Narragansett Bay Commission is a quasi-state agency that owns and operates the two largest wastewater treatment facilities in Rhode Island, Fields Point in Providence and Buckland Point in East Providence. These facilities discharge to coastal waters of Narragansett Bay. Narragansett Bay is a temperate northeastern United States estuary with complex channel embayment morphology. The Fields Point facility is located in the Providence River estuary. This facility was built in 1901. It's the second largest publicly owned treatment works in New England, and it's the largest wastewater treatment facility in Rhode Island. It has average flows of approximately 40 million gallons per day. Now we're moving upstream to the Buckland Point facility, which is located in the Seekonk River estuary. The Buckland Point facility is the second largest wastewater treatment facility in Rhode Island, and it has an average flow of approximately 20 million gallons per day. The NBC has a service area that encompasses areas of 10 municipalities in Rhode Island, highlighted in the map here. The NBC serves over 360,000 people, including 8,000 commercial and industrial users, and the NBC strives to be a leader in the protection and enhancement of water quality in Narragansett Bay. Wastewater treatment facilities are a source of nitrogen to estuaries worldwide. Nitrogen is often a limiting nutrient in coastal waters, and when nitrogen is combined with high water temperatures and sunlight in summer months, algal blooms can form. When these algal blooms die and sink to the bottom of the water column, decomposers that break down this organic matter remove oxygen from the water. If oxygen is not mixed back into these bottom waters through winds and tides and currents, persistent low oxygen conditions, or hypoxia, can occur. Hypoxic conditions can be detrimental to ecosystems and cause things like fish kills. Narragansett Bay experiences seasonal hypoxia, particularly in the Seekonk River and Providence River estuaries, as well as in embayments throughout upper Narragansett Bay, as shown here in red on the map. In 2003, there was a fish kill in Greenwich Bay. Though many factors beyond nitrogen, like stratification of the water column, contributed to this fish kill accelerated plans to initiate nitrogen reductions from wastewater treatment facilities in Rhode Island. Following this event, it was mandated that wastewater treatment facilities reduce nitrogen loading to Narragansett Bay by 50% compared to 1995 and 1996 levels. The Narragansett Bay Commission then received permit limits for total nitrogen of 5 milligrams per liter for effluent from May through October. To meet these permit limits, the NBC facilities installed advanced biological nutrient removal systems. These systems involve aerobic and anoxic zones. The aerobic zones convert ammonia to nitrate, and the anoxic zones convert nitrate into nitrogen gas, which then leaves the system. At Fields Point, an integrated fixed film activated sludge, or IFAS system, was installed. This system involves use of these wagon wheel plastic media to increase surface area available for microbes that are responsible for carrying out nutrient transformations to grow. Construction on the system began in September 2009, and operation began in late 2013 in preparation for a permit season in 2014. And this is the largest IFAS system in the world that's able to meet such a low nitrogen permit limit, and it costs $31 million. At Buckland Point, a 4-stage Barden-Froh process was installed, which operates during the permit season. This is a continuous flow suspended growth process with anoxic and aerobic zones, as shown in the diagram here. Construction on the system began in 2012. It was completed in 2014, and it cost $13 million. Before the system was installed, an upgrade occurred to an MLE system in 2005 and 2006. This MLE system has an aerobic zone and an anoxic zone, and is currently used in the off-season at Buckland Point. This upgrade cost $8.9 million. So here we have Fields Point and Buckland Point seasonal average effluent total nitrogen concentrations, which are the lines in the graph, and loading, which are the bars in the graph, from 2003, the year of the Greenwich Bay fish kill, to present, averaged over May through October. So from the graph, we can see that substantial declines in both nitrogen concentration and loads have occurred over time as nitrogen upgrades have been implemented at these facilities. At Fields Point and Buckland Point, for example, nitrogen concentrations average between 13 and 16 milligrams per liter pre-upgrades. Post-upgrades, these facilities now regularly see total nitrogen concentrations of less than 5 milligrams per liter and often less than 3 milligrams per liter. So here we're looking at average seasonal May through October total nitrogen loading from 11 wastewater treatment facilities to Upper Narragansett Bay. And here we have the year 2003, the year of the Greenwich Bay fish kill, compared to the years 2014 to 2020 as nutrient removal upgrades were going online. So in 2003, total nitrogen loading averaged 14,000 pounds per day from these facilities. Following 2014, these plants now average less than 4,000 pounds per day. This represents an average decrease of 77%. NBC facilities comprised over 8,000 pounds per day of that total load. Now, NBC loadings have decreased by over 83% from 2014 to 2020 and remain under 2,500 pounds per day. In order to better understand the impacts of these nutrient removal upgrades on receiving waters, the NBC has implemented a comprehensive environmental monitoring program which started in the early 2000s. This environmental monitoring program takes samples throughout Narragansett Bay watershed, in urban rivers, and in coastal receiving waters. For the purposes of this presentation, we'll focus on just a subset of these initiatives in the Seekonk and Providence River estuaries. So we're going to look at dissolved inorganic nitrogen, and nitrogen is sampled in surface waters 2 to 3 times per month in various locations in these estuaries. We'll also take a look at water clarity, which is collected via Secchi disc multiple times per month. We have data on bottom dissolved oxygen, which is collected at fixed locations in the Seekonk and Providence River on 15-minute intervals via sensors. And we have some benthic video information, which is collected via a sled that has a camera that is towed behind the research vessel along the bay floor. All of our data are publicly available on our Snapshot of Upper Narragansett Bay website. So here we'll take a look at dissolved inorganic nitrogen concentrations averaged seasonally from 2007 to 2020. Here, the shading on the graph represents categories from EPA's National Coastal Conditions Report. Green is good in terms of coastal nitrogen, yellow is fair, and red is poor. The sites on this graph are also arranged using a warm to cool color scheme from north to south. So Phillipsdale Landing, our northernmost site, is in red, and Conimicut Point, our southernmost site, is in purple. You'll see that dissolved inorganic nitrogen typically decreases as you move from north to south. These northern sites are influenced by freshwater inflows from urbanized areas in Rhode Island and Massachusetts, whereas the southernmost sites are more saline in nature. Additionally, you'll notice that rainfall tracks relatively well with inorganic nitrogen concentrations. With higher amounts of rainfall, we get greater loads of nitrogen coming in from rivers and wastewater treatment facilities. Additionally, you'll see dissolved inorganic nitrogen concentrations in the bay have generally decreased since the mid-2000s. In 2012, the 50% reduction in nitrogen loading was met by wastewater treatment facilities, and dissolved inorganic nitrogen concentrations have continued to decline since that time post-upgrades at all facilities. In 2020, we have some data from June through August, which shows dissolved inorganic nitrogen has been in the good category this season, and we've also had relatively dry conditions. One site, however, was in the poor category, Patuxent Cove. This site is influenced by freshwater inflows from the Patuxent River. Please note that our June through August data are somewhat abbreviated in nature. We've only had 1 sample per month due to restrictions from the pandemic. So here we're looking at water clarity at the same set of sites from 2010 to 2020. And again, we'll notice there's a gradient in water clarity from north to south. As we move down the Seekonk River into the Providence River, water clarity increases. Additionally, post-wastewater treatment facility upgrades, water clarity has increased by approximately 0.2 meters on average at our sites. Now we'll take a look at hypoxia at our Phillipsdale Landing site, which is in red and located in the Seekonk River, and the Bullocks Reach site, which is in blue and located in the Providence River. So this graph shows the percent of 24-hour periods with dissolved oxygen less than or equal to 2.9 milligrams per liter in bottom waters in both of these locations. And the data encompass the years 2007 to 2020. So here, again, we see that rainfall influences hypoxia at our sites. With greater amounts of rainfall, we have generally more hypoxia. Rainfall can bring in freshwater flows and increase density stratification. We also see reduction in hypoxia at our Bullock Reach site during and following wastewater treatment facility upgrades. However, rainfall has also declined during those times. At Phillipsdale Landing, data are variable, and they illustrate the importance of continuing to monitor at this location to discern long-term trends. Next, we move on to benthic video insights into water quality. The NBC takes benthic videos at the 3 transects shown here in the Providence River estuary. We've seen plenty of macroalgae on these videos, indicating that nutrients are present in sufficient quantities to stimulate primary production. However, over the past few years, we haven't observed extensive amphipod tube mats, which suggests lack of excessive organic enrichment, which is good news for water quality. We've also observed many different species like sea stars, moon snail, softshell clam, and black sea bass. Long-term monitoring data collected by the Narragansett Bay Commission have demonstrated water quality improvements in Narragansett Bay. Please note, the Narragansett Bay Estuary Program and other groups around the state and watershed are conducting comprehensive inquiries into changes in water quality in the bay over time. But these NBC data presented today illustrate the importance of long-term data sets and the utility of environmental monitoring programs in assessing success of various wastewater treatment upgrade initiatives. Additionally, data collected by the NBC monitoring program informs the Regional Ocean Modeling System developed by URI to better understand hypoxia based on environmental conditions and nutrient reduction scenarios. In closing, it's critical to continue environmental monitoring to ensure management of Narragansett Bay is based on sound science in the future. And with that, I'd like to thank all of the individuals at the Narragansett Bay Commission who are committed to keeping Narragansett Bay clean. Special thanks go out to the Division of Environmental Science and Compliance, particularly the Environmental Monitoring, Technical Analysis and Compliance, and Laboratory departments. Please feel free to visit our website, snapshot.narrabay.com, to download data and other reports. And thank you very much for having me as a speaker at the conference today.